Not. It means the room is half full. So you've seen the live logo that has just appeared because this conference, a large part of this conference will be broadcasted on YouTube. Not everything, or not all the speakers have agreed, but I'm happy to say that most of them have agreed on their talk being broadcasted, which is very nice. And so, without further ado, I'm going to welcome you all to this Nextflow BovReg workshop on reproducibility. You've been many to apply. We are overwhelmed and extremely happy with how successful this call has been. As you know, Nextflow is now becoming a very popular solution for pipeline and for reproducibility. And this workshop is actually the fifth of its kind. It started very, very low scale with just a few people. And we are now every year we've been growing a little bit. And this year we've decided to focus on, sorry, there's a bit of background noise. We have decided to focus on reproducibility on animal genomics. And this is because of our strong interest on BovReg and on all kind of consortiums dedicated to animal genomics. Now, I'm especially pleased to welcome to this conference the FAN community, lots of representatives of the FAN community, which is, as you know, a loose group of researchers around the world whose interests lie in animal genomics. And so altogether, we are now trying to build for the animal community what the ENCODE community has built for human data. Now, the timing is especially good because, as some of you know, NF Core, a new standard and a collection of tools based on Nextflow, was recently published in Nature Biotech. And this is really opening a new venue, especially because NF Core is now supported by the Chan Zuckerberg Foundation. That's really changing the game in all kinds of directions. And that makes the timing of a conference like the one we're having these days amazingly good. Now, this workshop will run over 4 days, which is quite long. And so that will give us a lot of time to interact, a lot of time to do, I hope, very cool things together. We will, as you have seen on the program, we will alternate keynotes, flash talks, and practical sessions. Some of the practical sessions are just, well, not just, they are Nextflow courses, which means that some of you, not necessarily very familiar with Nextflow or getting to know Nextflow, will get a chance to be run, to be driven through very precise Nextflow tasks, implementing standard things, standard tasks. And unfortunately, the course was oversubscribed. So we apologize that we were not able to fit the 80 people who applied for the course to the 35 or so slots we had available for this. But for those of you who want to do hands-on stuff, there is some more chance because the second type of hands-on session of the project will be the hackathon. And so during the hackathon, you will get a chance to do all kinds to apply Nextflow, the Nextflow technology, to any program that you feel relevant. So we've had quite a lot of nice projects from the hackathon. They will be introduced this afternoon by Jose, and you will see this will give you a chance to be hands-on. The hackathon is a very self-organized format, and I really encourage you to do whatever you like, to either join a group of people you know because you used to work with these people, or you should not feel intimidated if you're not top-notch, because the idea is to have the hackathon bridging technical levels between various kind of people, some people that are very much on top, some people who are just getting their feet wet with these technologies. I want to insist that we've tried to organize this conference as if it were going to be a real conference, meaning that we have rooms, we have breakout rooms. If you look at the icons with 4 little squares on the bottom of your screen, you can join any of these rooms at any time. You know, it's like a conference. You're looking for a quiet corner to discuss things with your colleagues, with people you've met. Well, you know, if the room number 1 is full, you move to the room number 2, to the room number 3. You're just polite, and if the room is full, you just not crash in and start talking very loudly with people. You know, it's really going to work like a normal conference. Even though it's virtual, we're going to do this as real as possible. I have to say, for us, Zoom has been a mixed blessing, you know, the Zoom era, because we now live in the Zoom era. I don't think we would have managed to have such a nice collection of speakers if it had not been for Zoom. So that's a good side. The downside, of course, is unfortunately, this is Zoom. This is not real. You're not enjoying the nice weather in Barcelona. You are not enjoying the very nice things we can do here. But that's life. We have to live with this. Now, let me start introducing the first keynote speaker we have that is going to start his talk in 5 minutes. Our next speaker is Evan Floden from Sequera Labs. So I'm especially happy to introduce Evan because Evan is a former student of mine. He graduated from the lab in 2018. Evan is a biologist by training. He's been really all around the world. He's a New Zealander by originally, and was probably involved in voting this amazing bird as the bird of the year. You know, I assume you have a right to vote on these things, Evan. You know, the parrot, the walking parrot that was just elected bird of the year. So I have to say, Evan has been an amazing student. 4 years in the lab, he managed to crank 2 Nature Biotech, which I have never seen the like of. I hope he is not the best student I will ever had, but he's been amazing. And his work, there was a lot of scientific work he did with Edgar on multiple alignments and things the lab is very much on the top of. But with respect to Nextflow, we have to credit Evan for spinning the project that was already amazing, but spinning it so that it became really noticeable to the community as a game changer. And this was the instability. It is Evan who figured out that there was intrinsic instability in all the pipelines if you did not run them on containers. And, you know, finding a problem is nothing if you don't have a solution. And thanks to Paolo, we had a solution. We had the Nextflow solution. And that really changed everything. That was a game breaker for us. This took us to Nature Biotech. And the story started then. And Evan, after leaving the lab, started with Paolo Di Tommaso, the Sequera Labs, a new company. And today, Evan is going to tell us about the way all these pipelining technologies are actually changing our world, changing the way we do biology, and how much of a major impact they're having on the reusability and interoperability of data in our field. So without further ado, I'm very happy to introduce, to let Evan talk. So I believe I have to mute myself and I have to unmute you, Evan.
Awesome. Thanks a lot, sir. Can you hear me okay? Perfect. Okay, great. I'll just quickly go over and share my screen. Thanks a lot for the introduction, Cedric. So it's always nice to be back in your company, even if we have to do it virtually. And then thanks a lot to the organizers for obviously for putting this together. I wanted to provide a little bit of background on Nextflow itself, provide you a kind of overview of everything that's kind of going on, the certain different parts of the project and kind of how it all fits together. But first, I'd like to start off with a kind of little bit on the origins of how this came about and what's the kind of problem that we're trying to solve. I'm sure many of you are familiar when you start to do any kind of bioinformatics analysis, you end up with certain problems which you hit, and there's a kind of common set of issues which we all face, and that's kind of some of the things that we started to tackle with Nextflow. First off, just a little bit on kind of how the course will progress, and hopefully after seeing my introduction, which is the first topic here, the other pieces will fit into place a little bit better. So I'm going to provide an overview of Nextflow Workflow Managers, the problem, and then for the workshop part of this, which Jose will take over, you'll be looking at your first Nextflow script. What do these things look like? How we can do this basic scripting, the various components of a Nextflow pipeline. These are specifically channels and processes. Finally, an RNA-seq example, and then you'll jump into the configuration side, containers and all of that good stuff. Starting off, so Cedric's kind of introduced me, but yeah, my background is in biology. I really got into bioinformatics, kind of seeing that biology was becoming very digital. Around 2012 or so, came to Europe and did a master's in bioinformatics, and of course, workshop part of this, which Jose will take. Oh, got some weird background, and then we have Paolo, who's also on the call, who will be doing some introduction later on. So when we think about data analysis pipelines or workflows, what do we mean here? We typically are starting with some input data, and we want to process it through a variety of steps. Now, here's a kind of idealized example of what that would look like. This is Sarix. This is an NF core pipeline, which is doing variant calling based on germline and somatic samples. And each of those steps is essentially taking data, probably as you know, in most cases as files. It's processing that data in each of those steps, and then it's generating some output, which is going on to the next step. Now, of course, you can have steps where you need to collect all of those things together. You have steps where you need to split them out, and then you generate some kind of report at the end. This is a very idealized view. In reality, and the kind of example I'm going to use here is the one that we used in the paper Cedric was referring to, is this parasite genome annotation pipeline. And these things can become incredibly messy. So each one of those circles there is a step in the pipeline. It's what we call a process. You can think of this as a task which has to be run. And each one of those tasks may have to run 1, 10, 1,000 times. And you can see how the data has to flow through all of that. Now that kind of looks daunting itself. And then you have to consider how you could then deploy that on different infrastructure. How could you manage that in a kind of production setting where you had to bump a version of this piece of software, for example? And it becomes incredibly challenging to do. And all of this, we can kind of summarize some challenges that we all face. So we now have all increasingly large data sets which we are processing. And a little bit different in kind of life science or bioinformatics than some other analysis, we're typically dealing with files. And these files are, you know, big, long strings, which we have to manipulate. We have to transfer to where we need to do compute. And we need to manage in this way. And this is slightly different from other senses of the word, you know, big data. When you consider something like big data in a database, where you have to hit a database, you know, 2, 3, 5, 10 million times to do some kind of ETL transformation. So we're dealing with large files. And this means that we can then parallelize those files at that level. What this means is that we can take these input files, split them up, and do what's called embarrassing parallelization. This means this is whenever you're using a cluster or a cloud in bioinformatics, this is what you're typically doing, splitting up the tasks to run in a distributed manner. We have a mashup of different tools. So you will take something from GitHub, some script you've downloaded yourself. Maybe you will take something proprietary even, and you need to put all of this together into this pipeline to develop. And of course, that comes along with massive challenges. So this complex dependency tree that gets built on this makes the configuration of each of those tools. I remember early on in sort of when I got into bioinformatics, I mean, particularly if you're not a particularly skilled computer scientist, I was spending the majority of my time just installing tools, like literally weeks just installing tools before you would even start an analysis. And this is something which obviously we has for the most part become a thing of the past for most people. Okay. So that pipeline I showed you before, it's like 70 different tasks here, all of these external scripts. What we realized is when doing this was that there was some differences when you were running these pipelines. So if you were to take a typical pipeline, this is an example of trying to reproduce a paper. In doing so, trying to replicate that paper, I estimate it takes around 280 hours just to actually re-implement when you've been given parts of the code, etc., to do. And this is obviously a huge waste of time and resources, but it also produces lots of challenges to reproducibility itself and actually being able to validate the science, which we all depend on so much. We can think about that as actually a different challenge though as well, in the sense that even if you are able to reproduce it, even if you are able to put all the pieces together, You get the same versions of the software. You get the scripts from a GitHub repo. Once you put it all together, you're still not guaranteed to get the same results. And this is what we showed back in 2017 with this Nature Biotech paper on a couple of different pipelines. One of this genome annotation pipeline, another standard kind of RNA-seq quantification, is that, for example, you were getting genes that were starting or stopping in different locations based on the operating system which you were using. So same versions of the software, etc. In the example down below there, we showed that the genes which were differentially expressed were different between different operating systems. And of course, this produces lots of difficulties in trying to make any sense of your results if these kinds of changes are occurring. I'll get to the solution in a moment, but kind of some of the summary of what we're trying to do to solve that in terms of simplifying this data analysis, both in cloud and cluster as well, is working on making sure these pipelines are reproducible. Kind of saw those examples before. We need to be able to get the same result, kind of full stop. We need to make sure that the pipelines are portable, and this is essential for collaboration, for sharing with teams, for even just working in different environments ourselves. These pipelines need to be scalable. We need to start on a small test data set, ideally do some development locally, and then when we need to apply it to our full data sets, we can scale up. This is just impossible to do development on a full data set. So it needs to have this kind of flexibility in this way. The validation is incredibly important. So we need to, particularly running these things in clinical analysis, that the results can be validated. People are working in highly regulated environments and usable between all different groups of people. Whether you just need to kick off a pipeline from a GUI, whether you are the workflow developer yourself and you need to run the pipeline, or whether you want to put this pipeline into a larger system, maybe via running it via an API, for example. We want to make sure that these pipelines are able to be run in all these ways. So that's the kind of the main challenges that we're going after with Nextflow. And this is a description now of what it is. So there's two parts to Nextflow and two kind of main components that you have to keep in mind. And one is that Nextflow is both a programming language. It's a DSL, so domain-specific language, and it's a way of essentially writing pipelines. But it's also a runtime, and that runtime enables you to execute on very many different platforms, what we call executors. So you can run these pipelines, you develop the code, what we call processes. You can write this in any language, R, Python, Bash. You can reuse your existing command lines. You then wrap these processes and link them together using data flow programming and define the containers. And all of this becomes a kind of Git project. So we kind of really took early on the idea that Git and version control was central to this kind of reproducibility. And from there, from your script, you can then run on any of these platforms. But importantly, you don't mix these two things together. So one of the real kind of patterns which we try and enforce here is that there should never be any config inside your pipeline itself. So your pipeline should not be like hard coded, for example, with a particular platform with where it runs. By keeping these things separate, very clearly, you're able to get this portability, scalability, reproducibility, etc. And you're going to make both your future self and also your collaborators much more happy when you do so. How does it work? So that's the kind of the high level pieces, but there's a few other kind of fundamental differences of Nextflow with other systems and how these come to work. So firstly, it's a DSL. This means it's a domain-specific language written on top of another programming language. That other programming language is Groovy. And Groovy is used in, for example, in Jenkins. It's kind of used as a build tool in some places, but you can think of it as like Python for the Java virtual machine. You don't need to know any Groovy to write Nextflow. But if you're ever in corner cases, situations where, say, Nextflow doesn't do something that you need, you have access to an underlying programming language to be able to help you. We use a model, this data flow model, which is very much like functional programming. This is probably best shown in an example later on, but what this means is that when we're developing our pipelines, or when we run the pipelines, it's actually the data, it's the contents of the channels which drives the execution of the pipeline. This enables us to get massive parallelization, and it's very different from like a make-like approach where you are starting from what you need. We are really starting from the top, so it's a push-like model. A key thing early on was keeping the idea that each task itself, so each submission, each kind of call of your tool, for example, is self-contained. This means that it lives in its own work directory. And then if you take this approach, it really ended up preempting much of the cloud technologies which came along later on. So if you have an idea that each of your tasks lives in its own work directory, it's independent, it could really become a containerized job. And from this containerized job, of course, we know that this has now become the main way of executing these pipelines, and kind of preempted the likes of AWS Batch and Google Life Sciences. Finally, as I said before, we keep these things separate between the definition of the workflow and the configuration. And this is really important for the portable execution. What does it look like? I'm going to show you two things now. First is the original Nextflow syntax, which we developed. And then I'm going to show you the new improvements, which were released earlier this year, which kind of improves things a lot. So in the first case, imagine that I wanted to do a task, BWA mem. I have the task itself. So this is a command line, BWA mem. I have a reference input. I have a sample, which I need to align against that reference, and I'm going to pipe it to SAM tools. With Nextflow, we simply wrap the original script section that we have, or the original task that we have, in inputs and outputs inside a process block. So you can imagine now I'm going to take that original script that I have. I'm going to provide a name for this sample, so a name for this process, sorry. I have two inputs, a reference and a sample. I have some outputs. This is what I want to capture, what I want to use downstream. This is the output of my task. And I have a script section which can remain exactly the same. Fairly easy to kind of follow, I think. But real magic happens when I need to do something with this output, when I need to use this thing downstream. And in this case, what happens is that we need to link now these two things together. How we can do that is via channels. So if I take the output of the align sample channel, and I use that as the input of this index sample process, I've now intrinsically linked the two processes together. And now, as soon as there is an output of the align sample, the index sample process will fire off. And it's this intrinsic linking of these things which provides us with this data flow approach. And of course, this can continue, and your whole pipeline develops this kind of the full dependencies of what's required. This is, I say, the first iteration of the Nextflow language. What we then followed this up with is very similar, but there is a subtle difference in doing so. And so what we have now with DSL2 is that we have the same syntax in the sense that you have a process, you have inputs, outputs, and a script section. However, now we don't link explicitly in the task definition the actual channels themselves. So you can see that this input has two channels, but I'm not explicitly linking them inside the task section. What I'm able to do then is have, in this case, a sub workflow or a workflow itself, where I can call these, you can think of them as functions, but I can call these processes with inputs themselves. And by doing this, we can create modularization of the pipelines. We're able to do heaps of cool things like unit testing. We can have workflows, calling workflows. We're kind of removing that with that separation, and also cleans up the syntax a lot for writing these pipelines. So you can see more on that in some talks on DSL2, for example. Data flow itself, nothing changes in the data flow, everything stays the same. You can think of this as each of your processes that we've defined, they sit there alive. They kind of sit there waiting to be executed. And as soon as the input is received via these channels, the execution of the task begins. So these channels are first in, first out queues, and they're essentially the linking, they're the plumbing between our processes. In practice, you can imagine that a channel would have 3 files. Imagine 3 FastQ files, for example. You define your process, and then however many files in this case that you had entering your process, you would automatically get the execution of that task, which would be submitted to cluster, submitted to cloud, run locally inside a container, for example. In practice, you can see that if I was to define a channel in this case with one sample, this processed fast QC would run once because I have one file inside this channel. If I was to take that channel and say, okay, now I want every FastQ in this directory, the FastQC process would run however many times I have in that channel. And that whole initialization would cascade all the way through the pipeline. So the FastQC channel, for example, would then, if that was going to be used as an input for next step, and the whole thing would trigger from this. This is a kind of another visualization of that, where you get multiple iterations. So we call these processes the definition of your execution that you want to run, and then tasks are multiple implementations or multiple iterations of that. We can handle much more complex things. It doesn't have to be single files. You can have more complex data structures, pairs of files, dictionaries, etc. And you can kind of have cases, special cases for handling all of those things that you process through. This is an example of something we do very often in bioinformatics, pairs of files. So for example, read one and read two. Okay, that was enough on the syntax of Nextflow itself. I want to now go into the other side of it, which is the configuration, which is the deployment, which is how we run these things. Because I think both of those two things are, they're very separate, but they kind of come together very nicely with what we do with Nextflow. The first thing to kind of keep in mind is how we can run Nextflow is just locally on our machine. If I just go Nextflow run, choose a pipeline, I'm going to be launching that with either Docker or Singularity. And then that pipeline is going to run on my local machine. Each of those tasks will be a POSIX process, kind of standardized way of running this, and kind of very useful for if you are, for example, running Nextflow for continuous integration or in your development. This is how you would typically run it. What's, of course, most common for people running in universities and research centers and large clusters is a centralized orchestration method. Here, Nextflow is the orchestrator and submitting those jobs to a cluster, to a HPC system. And typically this works via a shared file system, because you have to imagine that the files which you need to operate on, these intermediary files, have to be processed on the cluster node, and then they have to essentially be used by the next task. This is fairly easy to do in a way you can, and there's obviously support for, I think, so 10 of the main schedulers that you have for these kind of systems. What's become increasingly popular, though, is cloud. And I think it's one of the things that really made Nextflow stand out was this ease of use of cloud. It was essentially turning the cloud into something much like a university cluster. And this came about through a couple of ways. I'll skip that one. One of them was AWS Batch. AWS Batch is a computing service for doing batch-like computation in the cloud. And early on, we developed this executor for doing that very thing. So Nextflow submits each of its tasks to the AWS Batch API. And each of those tasks then, or API calls in this case, spin up a virtual machine with the correct number of resources. You define the resources, it defines the container you want to use, it defines the task. And then the S3 bucket, which will have the input data in, transfers that to the virtual machine. The task will run, and then the output data transfers back to S3. And all of this is then orchestrated by Nextflow. So the whole thing continues on very much the same way. The key to this, though, is like many things in computer science, the key to this is the abstraction. And what we're able to do is keep the same abstraction for CPUs, for memory, for queue, for container, all identical across all of the different platforms. So it doesn't matter to you as the pipeline developer, or even as the person running the pipeline, if you run on any of these platforms, because Nextflow kind of takes care of that conversion at that layer and how that works. We're really excited about what you can do in this space, because now we kind of have the framework for doing this, and all of the various technological improvements which we can get out of this can come true. So for example, we can now do shared file systems in the cloud, FSX, as a way of not needing to transfer their data from S3 to the virtual machine. We have some very exciting new stuff which we've been working on recently, which has enabled you to take the data and basically create a fuse mount onto the S3. We can really speed things up a lot here. And going back to the point at the start, a lot of the pipelines which we work on, they're very data intensive. We have huge files, like really massive, unwieldy files that we need to deal with. And a lot of the time, the computation that you're spending is actually just spending time transferring data up and down. And from this, you get a lot of wastage of your resource. So anything that can improve that can provide marked improvements in the efficiency of your pipeline, which of course we know can be very expensive to run. There's a whole bunch of other things. So there's also Google Cloud Life Sciences works in a very similar way. And we're also really excited about Kubernetes execution. This has been used by some sort of large institutions. We think that this will be kind of something which is going to happen over the next 5 years or so. People will move to a kind of more cloud native like orchestration once the tooling sort of improves enough that we can don't necessarily need to rely on the cloud providers' sort of homegrown solutions. Okay. That's the kind of different ways of running the pipelines themselves. I'll just say a quick section on how we actually keep these things different. So how do I keep the workflow execution, the workflow definition separate from my configuration? Well, I would define my pipeline here as shown as a script. I could run Nextflow run. It would run on my local machine. I could then add in the configuration a section on, for example, Slurm. I would say I want to run with Slurm. I would put my queue in, how much memory, CPUs, etc., a container, and then I would run Nextflow run, and it would run on Slurm. Notice that I didn't change anything in the script. The next section I could go, okay, now I want to run this in the cloud, same pipeline. What can I do? I'll just simply change out the executor, but notice that the abstraction is the same. So we still have the same abstraction for a queue, for CPUs, for memory, etc., and for container. And now I would be running in the cloud. And keeping this in mind is really important for developing your pipelines in the future. Okay. Other things that we can do. So containerization is, of course, central to all of this. It's really what enables us to create this portable executions. We don't have to install these things. How did it come about? So early on, there was kind of use of virtual machines for some kind of bioinformatics pipelines. But these were typically a situation where you would create a virtual machine. You would go through the same process that you would do on your local machine. So you would install all of the steps, and then you would save that virtual machine. And every time you went to go run the pipeline, you would boot up this virtual machine, run your pipeline kind of in a standardized way, and exit out. There's kind of some challenges with that. Firstly, the virtual machines are very slow to start up. They're typically very large as well. So like the images themselves were not very easy to handle. There wasn't really standardization around the use of them in kind of across different institutions or across different infrastructure. And they were kind of changeable over time. So you could boot up a VM, save something, and then you would have a different version of that VM. Containers, on the other hand, have some big differences in that they're able to start really fast. We're able to essentially define a container, and every time we start the container, it's immutable. It starts up in that state. And we can compose these containers of layers. So I can have a base image of a container, can add a layer to it, and I don't need to re-download that whole thing again. I can actually use various components of the container to be kind of composable. And of course, Docker was the big kind of pioneer here. And this sort of started off with back in 2014, where Paolo was watching some talks from the guys on Docker and really realized that you could take this idea of using containers as services. They were essentially being used for web services, long-lasting jobs. And maybe you could apply that to what we do in data science or what we do in bioinformatics. We could take this concept, apply it to that, and it's going to see what would happen. Oh, sorry, I pressed a button there. Okay. I'll go back to share my screen. Sorry about that. How it kind of works in practice there. So you have these, you have the idea that each of our tasks we're submitting, you remember that these are like kind of immutable jobs, that they are single tasks. What we do is we simply wrap them in a Docker container. So we wrap them in a Docker run. So instead of running my shell script, I'm now going to be running a Docker run inside my shell script. My shell script will run inside the Docker container. There's also support for other containerized engines. So there's Singularity, which is used in HPC, Podman, also some other ones. But the main point is that they're all very using common ideas and very much based on a common kind of container format, which enables kind of interoperability between the containers that you use. So when to use containers, I would say always. Like, one of the great things I hope we can get out of this is that really take the time and effort to get your head around containers. There's some really nice stuff in the workshop on how to do this, like independent of Nextflow, independent of workflow managers. They will save yourself a lot of time, and once you get comfortable with them, you can't really turn back. It's really is a really dramatic change in how we develop tools and distribute them. Okay, some other cool things about Nextflow. So we have like execution reports, kind of building an ecosystem of these things. Some of this is driven by some of the other communities that have come up from Nextflow. We really wanted to build this ecosystem around it to make the lives of developers and bioinformaticians a lot easier. Code editors, for example, so you get syntax highlighting of Nextflow itself. But there's also support for some standards, which we're part of. So there's Global Alliance for Genomics and Health. This is a couple of different parts to this. One of them is at the task execution layer. So coming up with an API, which Nextflow supports for submitting each task, is a kind of common API across different executors. And we've recently added support for the workflow execution API. And this is part of Nextflow Tower, which I'll show you in a moment. But it's an API for defining how a workflow can be submitted or executed on different platforms. So there's support for Nextflow in there, there's support for WDL, and there's support for CWL across a few different platforms here. This is, just keep in mind, this is at the kind of application layer. The growth of Nextflow has kind of been really dramatic, particularly the last couple of years in terms of downloads, active users, the community that's come about from this. And this really just seems to grow from strength to strength. And the kind of adoption that we've seen, of course, it's still, a lot of this is in academia or in kind of government research, but there is also a large fraction of this of people who are running in production. People who are running in cloud, people who are running kind of large data sets for part of big projects of this. And this is just a small selection of the enterprises who we know of who are at least running or using Nextflow to various degrees. And of course, more being added to this all the time. And that's kind of very, very promising for us because it's really sort of shows that there is a widespread adoption of this and also widespread usage across many different types. So people are using this for all sorts of stuff. And increasingly now we see, for example, in radio astronomy, we're looking into applications of machine learning. Anywhere where you have this kind of embarrassing parallelization across different infrastructure, we see is a real big strength here and something that we're working on a lot. Another thing we're working on is been with NF Core. So this is another project which has grown really massive over the last couple of years. I think there's up to now 1,000 people in their Slack channel now, which I would encourage you to go join. And as part of NF Core, it's really about defining this collection of pipelines. I think there's going to be some talks later on this, so I don't want to dwell on it too much, other than say we recently got funding from Chan Zuckerberg Initiative as part of Nextflow and NF Core. And there's some really nice work in terms of developing production level pipelines, which of course you can just click and go. Other things that we've been working on is kind of expanding the things that you can't do with Nextflow. So Nextflow is great, but it still has some limitations to it. So it's a command line tool. As I said before, it's a kind of language and a runtime, but it's kind of was lacking some things that you wanted to be able to do that you can't do from a command line tool. many of the things that came about from when we started getting into this was still a lot of difficulty with people configuring the cloud. People who wanted a lot of kind of concern around how we can track the history of our executions. This is, for example, very important for provenance. So going back, just being able to share your pipelines, share your executions with people, and kind of doing the things that you need a server to do, things that you need long-running jobs, things that you need to keep track of. And Nextflow, being a command line tool, is of course limited in that regard. So we developed and just released just over a year ago now. This is available at tower.nf is Nextflow Tower. And this is a centralized orchestration or a centralized location for execution of your Nextflow pipelines. And the idea of this is that we wanted to bring kind of a GUI mechanism to it, but also to allow collaborators to work together, centralize your execution of the pipelines themselves. I'll quickly just jump over and do a very short demo of how this works. So I should state that Nextflow Tower is available free to use at tower.nf. The kind of model behind this is that we deploy this into pharma companies and the like who want their own personalized deployment of this. So you can sign in with GitHub, with any kind of login system that you want. There's also Google login. And what we have is kind of history of our executions on the left-hand side here, but we can launch pipelines themselves. So remember that every Nextflow pipeline is a Git project. So I can launch a pipeline, and again, keeping to the principles that we set, could choose where do I want to launch this? Do I want to launch in AWS, Google? I could even launch in Slurm if I wanted to. Enter a pipeline name here. I'm just going to run a basic RNA-seq one. Here I could enter a revision. So this is a tag, a git commit, a branch that I wanted to run. And I could choose a work directory or some Nextflow profile if I wanted. Once I launch this pipeline now, you have to imagine that this Nextflow job now is going to be submitted to, in this case, batch, or it could be to Slurm. And then from there, the individual tasks themselves will be executed out. And I have this kind of centralized now method to manage these pipelines. What's pretty cool though is that now we have a way of kind of tracking that information. We can really now dive deeper into it. Previously, when you run a pipeline, you can think you have tens of thousands of tasks. These are all really distributed, and debugging this becomes a real mess. What we're able to do now is access very quickly any of the individual tasks themselves and dive deeper into the actual output of that. Let's do an example. So let's say I had this example pipeline I ran before. I could now jump in. I get some general statistics, information on tasks, on the processes, etc. But I could jump into the task table and find out, okay, what was actually happening in the index step. I could see that this was running salmon index with this threads, etc. And I could jump into the execution log. Again, remember, this is independent of any platform that I've run. And I could go in and see the actual standard error that I wanted. I could go and get the log file, for example, or get the standard out and download that and run through. This makes it very easy for debugging these tasks. I can get information on CPU usage, memory uses, etc. What I'm also able to do is follow along live. So I could watch this execution log. This is running in batch. It's the same output you'd get from running Nextflow in the command line, observe all this information. I could even share my pipeline here. So I could, for example, add a collaborator in here. If I add it in here, anyone who's on Tower can get this. Paolo can then see that execution. He could follow along live and even rerun that if he wished. Other things that we're doing here is building support for the various compute environments. So we're adding in, we've got Slurm, IBM LSF, Batch, of course, Sun Grid Engine or Univa Grid Engine is coming in soon. And kind of simplifying that whole deployment for people. Finally, there's credential management for running Git projects that are private, GitHub, GitLab, Bitbucket, your cloud credentials, for example, and then really getting onto some automations. So enabling these pipelines to be automatically executed based on events. So a Git commit or some data in some S3 bucket, for example. Lastly, I point you to, if you're interested in this, we just have recently released some documentation on this. So this is at on tower.nf, there's help, and there's a kind of description of all of these all of these things that you can use. And what we're really excited about as well is the API for this. And this is kind of took a lot of work to get to. But from the API now, we'll be able to, for example, here you can do any of these actions. So anything that I showed you in the GUI, you can automate, and there's a lot of work going on this at the moment. In terms of the use for this, again, you can now imagine that you can share your pipeline. You could have other people in your lab kick the same pipeline off based on just changing some input data, for example. The deployment of this is it's a little bit more complicated than Nextflow. So Nextflow is like a one-liner. This is can be deployed in this case in AWS, but on any of the various clouds. Kind of takes a microservices architecture so that we're able to deploy this in different environments. As well as this, so I've showed you the sharing and collaboration, some of the new features that we have, some documentation we've recently released. And moving forward, we're going to go with this in a way that we want to extend the application out from being a kind of user-based application, where it's just a single user owns a compute environment or owns a workflow or owns a pipeline, and really expand it out to have the idea of workspaces so that you and your collaborators can have a common workspace. There can be an admin who can provide those resources for you. And what this will enable is people to, for example, set up a cloud environment for a group, set up a cluster environment for a set of collaborators working on a particular project, and then the users can simply log in and run their pipelines in this way, and kind of all of the kind of role-based access, which comes with those types of things. Talked about the API. Some also exciting things we're doing on resource optimization. So now with the history of that, we can create configs on the fly. File transfer, so speeding up this transfer of data. Building the containers on the fly for you. This becomes a big challenge for people, and kind of validation of those pipelines as well. Okay, so that's the kind of closing of the introduction I have. I'll just go to the questions now and see if there's anything on that, and feel free to ask any that you have.
Evan, thanks a lot. This was a great talk, very informative and very interesting. So we will now be happy to take any question you guys may have. So just raise your hand and I will unmute you if you have any question. I'm just keeping an eye on the... So while people are gearing up, I actually have a question, Evan. And that has to do with, as you know, I'm very interested in the integration of pipelines and publications and all these type of things. So do you have any plan of Nextflow or Nextflow Tower moving into providing some further integration into Ocean Code? As you probably know, Ocean Code is one of these lab book languages like Jupyter that is making it possible to wrap into the publication some kind of computation, you know, so that when you see a figure, you also have behind the figure the container that is actually producing the figure and all these kind of things. Do you have any plan in this direction?
Yeah, I think the challenge there that we've always thought about was maybe slightly stepping back from the publication, but in the same vein is this combination of how do you put like notebook computing, like interactive computing, and combine that with batch computation where you need to distribute the tasks. What we've been thinking about now is that, so notebooks, particularly like Jupyter notebooks, which is kind of what CodeOcean is built around, is very popular in machine learning. And we think that will be a kind of interesting take that we'll do as part of that. So kind of developing a data science like platform using Nextflow, which would integrate notebooks into that, and then kind of dive probably more into the machine learning part of that. So it's definitely in the plans. I don't have an exact timeline for when that comes about, but certainly something we're going to be exploring a lot more. It's very interesting as well how you can combine these things. It's still a big challenge for most computation.
It will have a big impact on publications, I believe. Now, as you talked about machine learning, just a naive question, So machine learning is pretty much about training and GPU and all these very, very intensive small processes. Is Nextflow agnostic with these kind of things, or is there any development plan into the direction of making machine learning easier?
I don't see any technical challenge in what Nextflow is doing. We can use GPUs, we can use any AWS infrastructure. I mean, it's really about the transparent use of any resource that you have. The challenge is creating examples and say replicating what we did with Nextflow in terms of the bioinformatics community into different communities. So coming up with examples. I have no, I don't really have much background in machine learning to come up with that kind of content for those developers. I think is the main challenge here. But I've got some people working on it now, and pretty excited to what we're going to do here. Keep posted. I think a couple of weeks there'll be something out.
That's very nice to hear. Do we have any more question here? Okay, so in any case, the speakers will hang around. And as I mentioned before, we have all the breakout rooms. So do not hesitate to engage them directly if you have any question, because sometimes, things are technical. So you'd rather talk to them directly. PM them. So Paolo and Ivan are currently in the conference room. So you can engage them directly and ask them questions. The next part of the next part of the conference is now going to move into the Nextflow training, where you're going to have hands-on experience on Nextflow and on how to use Nextflow. For those of you, unfortunately, as I mentioned before, the training is not open to everybody because we had some resources limitations. But I hope we'll be able to catch up in the future. In the meantime, so we're going to have Nextflow training until 12:30, and at 12:30 we will resume the talks with two flash talks, one by Daniel Fisher on switching from SnakeMake to Nextflow, which is a bit like switching from PC to Macintosh or something like this. So it's important. It's important to realize that it's a live ecosystem, and you want to keep your eyes on everything that is going on. And another one will be on a more biological project by Juliana Meneses on using these pipelines to study the dynamic transmission of resistance in enterobacteria. So I'll be back with you at 12:30 sharp. Well, I will introduce Flash Talk. And in the meantime, I wish all of you who are going to go through the training that they have an interesting session. Talk to you all again in a few minutes.